Hello again. So my name is Luis Oliveira, and this is the second video of me learning um, on the Databricks Academy. So if you saw the first video, you know. If you don't, you didn't, then the first what I do here is basically a no nets video where I am learning and you will be learning as well in the Databricks Academy. So let me share here my screen. And this second video is regarding the RAG. They call it from prompts to RAG. Okay, so let's see what we have here. So how do LLM1? So the LLM can learn in the three different ways. So LLM can learn. So can learn by pre-training, by fine-tuning already pre-trained, okay, or they can have passing contextual information. And this is where the RAG, passing contextual information. So basically it's this plus this and adding an extra. Requires external knowledge and how to use vector search. Well, so passing contexts helps facts recall. Okay. 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 Passing context to LLMs helps factual recall. So we pass a context as a model input. Okay. So we help on the prompts. Yeah, take an analogy with the open notes. Yeah, when I took some exams on the university, I had some books. It was the hardest courses actually. Yeah, so LMs are environment to accept a larger infinite input token. Okay, downsides, it's more expensive, of course, longer competition, contents domination in the middle may be overlooked. Okay, lost in the middle, and the needle on the text best. Yeah, and ongoing research to address context limitation. So what is a RAG? RAG. What is a RAG? So RAG, retrieval augmented generation, it was coined in 2020, already 6 years. Fantastic. It's a pattern that can improve the efficacy of LLM application by leveraging customer data. So we have a prompt, we have a query, and we retrieve domain specific context. Okay, cool. So it's done by retrieving data documents relevant to a question or a task and providing them as context to augmented. Yeah, exactly. So augmented the prompts to improve, yeah, generation. Yeah, I can see this as we have the one how it was. The technique was the one tip that we had to add more examples. Yeah, so in this case, we are adding more example, but with information. Nothing more here. All right, resolve it. So RAG is the main problem that is solved with RAG is the knowledge gap. So this approach enhances the accuracy and reveals the response. Okay. Main problem solved. Solved is the knowledge gap. Knowledge. Okay. So RAG use case, some practical use case. So we have here the Q&A chatbots incorporated in LLMs with chatbots to automatically derive from more accurate answers, uses automated customer support. Yeah, that makes sense. So if I go to a site which has a chatbot, then if I ask something related to the company, yeah, it must know lots of things about the company. Search limitation, incorporating with search engines. Okay, so it will make it easier for user to find the information they need. Makes sense. And also content creation and summarization. We facilitated development of high quality articles. If we provide several articles with the same information or similar information, ensure news and summarization. Yeah, okay, cool. Let's go main concept. So now we have here the main concepts that we need to know for the exam. Well, to know actually. Index and embedded. Okay, that embedded model used to creating embedded model. Okay, used for creating vector representation. Okay, okay, embedding model to create vector representation. Okay, cool. Then vector store, the second main concept, vector store. Okay. I assume it's a store where I go get the vectors. Designed to store unstructured data index by vector. Okay, so we convert unstructured data into structured data. Let's say this. Yeah, vectors that can be stored in a vector database. Cool. So store. Another concept is retrieval. That is actually the first name of that. Such store vector. So it goes from here, it goes here using similarity. Okay, okay, cool. So it's use similarity search on the vector store. And then filtering and re-ranking. So based on the similarity, it will, sorry, I have my notes. Filtering and re-ranking. I assume this is the process of selecting and ranking this. So yeah, makes sense. So this is kind of order ranking, the process selecting and ranking. Oh, one more, two more actually. Then prompt augmentation. So prompt engineering workflow to enhance context via ingestion of data retriever from the vector store. Okay, so we are improving the prompt. And finally, generation. That is also something that belongs on LLM. Large model used for the response. Okay, yeah, this we don't need to point. Next slide. So here we have then a document that is embedded. Okay, document that is embedding. Here we have documents. We do the embedding model. We got the vectors. We have some similarity. We get the similarity search. The user provides ask a question. Then this is similar chunks or documents are passed to the context, and then the final model provides the user. Master let me go here back, so I can be here as an example using PDFs. Okay, which is what we cover on the demo. The first step involves ingesting models, a process that can be done once. The schedule after the ingestion, document may be chunked into smaller pieces instead of embedded them in single block. Each chunk it then is converted into one own vector. In Databricks tools like the DLT can help with ingesting both structuring structured data. And once the text is ingested from the Databricks Foundation models from model is out of the box and third parties such as on OpenAI, yeah, supported by model. And cool. And here, now focusing on the dense on this user query. Dense here what when the user asks the question, that question gets converted into its own vector embedded. Okay, this is converted into a vector, and then it's doing the similarity. Okay, these branch value documents are more relevant to the user. Cool. And then once the relevant I retrieve the process, move it to a in context center or the inject into the branch. Okay, combine the does build. This model resolves those steps. Cool, 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 cool. So benefits of Hack. Up to date and up to date and more accurate responses. Responses are not based solely on static training data, and the model uses up-to-date external data. Okay, and reduce in response or hallucinations to mitigate the risk. What's can include? Yeah, of course. I assume that yeah, domain specific. So it's domain specific. So if I'm a finance company, it will be more specific to my company and what I have my products. Improve the accuracy of the response by using contextual reference. So, okay, so it's more domain specific textualization, efficiency, and cost. Yeah, because it's fast. Offers an alternative to fine tuning by without upfront overhead of finding tooth. Yeah, of course, it's faster. And cost effectiveness. Okay, mapping the RAG workflow to Databricks. So I find a relevant context, such as vector search, built into Databricks intelligent platform, integrated with the governance and productivity tools that are pretty cool, create and automatically sync. Okay, this is what we saw before. Pointer is enabled to mosaic integrated fields, vector search tips selected directly in the DLT, which are automatically updated and sync into enterprise data models, serving then generates and deliver reports in real time, supporting both cutting edge foundations, such as LM or external such GPT-4. Okay, so then the response is also a model serving state-of-the-art foundations and made available, and Mosaic interact with supported. This is what we have on Databricks. Pretty cool. So I'm going to point these features that are very important. Databricks features. I have to have fun a little bit with these features. Sure. So we have vector search, we have model serving or generate, or model serving to serve the run change. To generate or to serve. Okay, thank you. And the next on this course, it's a demo. So if you're doing this with me, please check the demo. It's pretty cool. The next one, the next slides that we're going to check is preparing the data for RAG solutions. And thank you for being there, and hope you enjoyed it.